Okay, I think I will just sort of kick things off and welcome everyone to this SCVP Journal Club. This is the inaugural journal club of our society. I'm very excited that you all can join us, and I know more people will be jumping on in just a minute. I just really want to thank the people who made this possible. Julia Damati came up with the idea that we should do this a year ago, and then it sort of festered for a while, and Brandon Larson further developed the concept behind it, and then Peter Wang enthusiastically took it over this year, just a month or so ago, and really drove this thing forward and enlisted Dylan Miller to be the first presenter, and then a whole lineup of people who are going to be following Dylan month after month. So I hope people can join us every month for this. This information, anyone on the call is invited to participate, and then we're going to put this on our YouTube channel and share it with the rest of the world so people can watch it and learn from what we're going to say. So all these are going to be recorded as well if people can't make it. With that, I'm going to turn things over to Peter, and he can present Dylan and we can start.
Yeah, Dylan is familiar with everybody, so I don't need to introduce him. So what I want to say is, if anybody wants to join our club, host the session, please let me know. Now let's start with Dylan.
All right, very good. Thanks a lot, Peter. Thanks, Mark. Whoever goes first gets to get out of jail free, right? Or let's see. It can only go uphill from here, at least. My screen coming across okay?
Yep.
And if I do the slideshow-y thing?
Pretty good.
No, looks like that didn't work. Hang on. I gotta just do the old-fashioned. Let's see. Oh, I don't know why I did that. All right, how about we look at it this way? Just zoom it in like that. Well, thanks, everybody. It's nice to see friendly faces, and I'm sure you have lots of cases to sign out. So I hope I can keep this engaging and keep your attention. I will allow anybody to use their microscope and sign things out as long as it's a heart transplant biopsy. That will be permissible in the next hour. So I've chosen the topic for my journal club to be sort of the origin story of the molecular microscope, or MMDx test, that's being marketed now, and I think is something that's relevant, even though these papers are getting 5+ years old. I think for our practices, this is something that's becoming increasingly germane and important for the folks on the call today to know about. There are many more papers from this group talking about this test in heart transplant. It's also used in basically every other solid organ transplant, especially kidney, where it was first developed, and we'll talk more about that. So both of the papers are from the JHLT journal, and I don't have any conflicts or financial disclosures or anything like that here, but I should certainly say that I claim no expertise in the area of developing molecular tests. And so in preparing for this, I did try to educate myself a little bit on some of this. And so I commend to you a couple of papers that talk about this, one from UC Davis and UAB group talking about expectation, validity, and reality in gene expression profiling. And another that's a book chapter from a book called Genomic and Precision Medicine that deals with developing evidence to support clinical use of genomics. So I wanted to start just with a few slides of some of the concepts I pulled from sort of teaching myself about how to develop a good molecular gene expression profiling test. And so one of those is the concept of analytic validity, which is basically the ability to measure what you say that you're measuring. In this case, a set of mRNAs in heart biopsy tissue. And so as part of that, recognizing that factors outside of your instrument, outside of your methodology, can have an impact on that ability to measure RNAs is important. So that's kind of the second bullet point. And that, you know, intra-assay type things, so realizing that there's a dependence on the analytical approach that you use, such as calculating summary scores and adjusting for within subject variation using kind of internal control idea of housekeeping genes and an overall gene expression. Just as kind of a practical example of this, there was a paper in 2014 by a group that took a gene expression test that had been developed using a chip microarray based platform, and they converted it over to more of a next-gen sequencing RNA-seq technology. And something that's pertinent to our discussion today is that one of the things that this group reported is that although overall the results were highly comparable, whether you were using chips or the next-gen approach, where they saw the lowest correlation was in our mRNAs that had to do with immune pathways and stroma-based pathways. And since what we'll be talking about today in the world of heart transplant biology, those are two heavy hitters, the immune system, obviously, and stromal changes. And so important just to recognize that maybe this is a signal that those are a little bit more finicky or maybe more difficult to assay than some of the other tumor-related expression signals. And the second concept that's important to keep in mind as we talk about these papers is the idea of clinical validity, and that is establishing an association between the results of a test and the condition or outcome of interest. So really to sort of maximize your clinical validity, it's important that your population that you use to develop the test isn't too narrow or homogeneous. You want it to include as many of the potential people who would be tested with this test at the outset as you develop and train the algorithms and things like that. One other pertinent thing from these papers is that, and this is definitely true in heart transplants, but there is a susceptibility to repeat biopsy bias, especially with heart transplants, where if you're taking, say, just your heart transplant population, anybody who has a positive biopsy is going to have follow-up biopsies after that. And so it's not going to be one biopsy per person in most of those populations, but you're going to enrich for rejection biopsies just by nature of that. And then just a paper that was quoted by, I think in the book chapter, that in the cancer world, there's sort of this dogma that you really do need thousands of samples to generate a robust gene list for predicting outcomes in cancer. And at this point, the MMDx test isn't really claiming anything about predicting outcomes. But certainly, I don't have data or evidence for this, but I think transplant medicine is at least as complicated as cancer, if not more. And so I think that having somewhere in the range of thousands of samples is probably important if you're going to develop a robust gene expression system. So with that kind of background for us to be thinking about analytic validity, clinical validity as we develop a test, this is the sort of origin story paper for MMDx in the heart transplant population. So it came out in 2017. It was a collaboration between the Edmonton group, the Paris group, and the Bologna group. And some of the authors here are members of our society. Big round of applause for the folks from SCVP who participated in this. In terms of the aims of this paper, so they state that, and I think this is sort of a first maybe point of discussion, is the hypothesis for the present study was that rejection in all organ transplants has molecular similarities, making possible the use of molecular knowledge derived in one organ transplant where phenotypes are better established to guide the classification of biopsy specimens in another, where phenotypes are less clear. This hypothesis is supported by the similarity in inflammatory lesions and molecular disturbances between endomyocardial biopsies and kidney biopsies. And I've got one slide to kind of talk about that. So actually, I'll show that slide now. So in terms of this idea that they're seeing similar molecular signatures in heart transplant biopsies and kidney transplant biopsies, this is data not published in this paper, but was in a poster that was presented around the same time. Over on the left-hand side is the kidney molecular signature. Obviously, many more data points in this graph. On the other right-hand side is the heart, smaller sample set. And so they claim that these are, close enough that they think that it's evidence that the molecular pathways are the same in kidney and heart. And, it all involves T cells and probably macrophage lineage cells and probably some stromal changes. So I think intuitively that makes sense. But, if you look closely at this, I certainly wouldn't say that they're superimposable. And, just thinking about analytic validity and I guess clinical validity, what were the negative controls that they used in this? Like, how do you know that any tissue that you put in the machine wouldn't get a gene expression signatures from whatever inflammatory cells are in the tissue and give you something similar? But that's sort of a premise that they're operating from, that whatever molecular signatures happening in kidney biopsies will also be in effect in heart transplant biopsies. So this is sort of their research strategy, or how they went about this. So they talk about work done previous to this paper in the kidney transplant world, where they developed these things called RATs, the rejection associated transplants, and then do some work like I showed you in the last slide to show that there's similarity in how these probe sets pick up signals in heart and kidney transplants. And then really the bulk of this paper was that they tried to kind of fine tune those algorithms so that they weren't bluntly applying the kidney probe sets to heart, but they found from among those kidney probe sets which ones were the most informative in the heart. And so I think that's makes sense, and I that's admirable. I think my concern about this strategy is that way before here, before they developed this in kidney, any potential transcripts that weren't active in the kidney that might be informative in the heart were automatically excluded from their overall process, right? That since they only started with things that they found to be significant in kidney, they potentially are excluding a large set of things that may be informative in heart. So back to the analytical validity question. I was ready, I had my tools ready to sort of pick apart their methods. And this is all that the paper really tells us about their assay and the assay performance, which is that they extracted RNA and put it on Affymetrix chips. So kind of not a lot more to say about what we can confirm as a sort of critically about their analytic validity in that paper. In terms of clinical validity, so they had 331 patients. It's not thousands, but it's a respectable number, with about a third coming from each of the centers. As you kind of tease the data apart, though, it's important to note that for all of the Edmonton patients, the 97 patients, they didn't have DSA for 67 of them. And the quote from the paper that actually they also didn't have PAMR scores for any of the Edmonton biopsies, and yet all of those patients were included in the analysis. And so I think one could reasonably question how come those were included when you didn't have the histology necessarily to correlate with, at least not for AMR. And they aren't really clear about, all these patients were included even though they didn't have AMR scores. So I don't know how they dealt with that. This is a table I just put together from their numbers too. And I think we learn important things about the population from this too, that, if you look at the range of biopsy post-transplant dates, it looks fairly similar, obviously the longest from Bologna. But if you look at the mean and median post-transplant dates for the biopsies, clearly it's kind of different populations, where the Bologna group are out in the 4 or 5 year range for the mean, and in the couple of year range for the median. So not a lot of first year biopsies, which is the majority of biopsies that we do at our institution. The Edmonton group is much closer to transplant, though. The median was within the first year, but the mean is only less than a couple of years out. And then the Paris group kind of in between there. And so not necessarily homogeneous. I think collectively it would span an important time, but kind of as we talked about before, processes happening in the first year after transplant versus the 10th year after transplant are probably pretty different. And so using the same gene expression signatures may not be the smartest thing there. And I think another thing, so this last line is the median follow-up from the biopsy, and this gives you an idea of sort of how recent these patients were. So most of the Bologna patients have like a year of follow-up, so they were probably fairly recent in their program, whereas the Edmonton patients are going back 10 years or so. So it's a kind of a different era where these biopsies were taken, and that may explain why they didn't have the AMR studies or DSA in that population. So again, just kind of important things to think about in terms of clinical validity of their population. Taking kind of a tangent, something that's not talked about at all in their paper, but I think is really important, and certainly we recognize as cardiac pathologists, rejection grading is pretty easy. It's dealing with all the artifacts that are really the challenge, right? And so this study did not consider the effect of quilty, which certainly would elevate the lymphocyte and immune system level of mRNA that was in the tissue, or healing biopsy site that we see that we see frequently in our biopsies. And it's easy to understand why they didn't include these, just because it's impossible, right? So this is inherent to any type of tissue gene expression profiling test. You can either know what the genes are, or you can know what the histology is, but you can't know both of those. So the sort of analogy of Schrodinger's cat comes into play here, and they can't, even if they had 4 biopsy pieces, let's say, and they sent 1 for molecular and kept 3, if there was quilty in a couple or even all 3 of the histology pieces, that doesn't necessarily mean that there would be quilty in the 4th piece. And if you didn't see quilty in the histology pieces, it doesn't mean that there couldn't be quilty in the piece that was sent for molecular. So I think that's an important limitation of this test that we should keep in mind. All right, so let's get to their data. So table 1 of the paper kind of shows their comparison between the histology, pathology, classification of the biopsies, and the molecular archetype cluster and median archetype scores. So a couple of things just off the bat, again, thinking clinical validity and thinking about their study population, and does it sort of match who they intend to be testing. So they have, out of the 330 patients, 100 of their biopsies were said to show AMR. And remember, we didn't know the AMR score for all of the Edmonton cases, so I'm not sure how that fits in here. But so that's kind of interesting in terms of, this wasn't a targeted accrual where they wanted to get a certain number of AMRs. This was just all 4-cause biopsies. And so I think that stands out as kind of something unusual, that a third of their biopsies had AMR in these three populations. And then interestingly too, that there's cell-mediated rejection, and they're using these funny abbreviations. So TCMR1 is the ISHLT1R, and then 2-3 is the 2R and 3R rejection. And so they had 113 of those types of biopsies. And curiously, they had almost as many really 2R, 3R rejections as they had 1R rejections, which I haven't seen that in any program before either. 2R and 3R have become pretty rare in most of our programs. So that's kind of interesting, just thinking of clinical validity. And then in terms of how the tests performed, so 100 patients that had AMR, and out of those 142 showed the archetype cluster that would have predicted AMR using their molecular expression signature. Of the 113 that had cellular rejection, it's 24 out of 113 that sort of hit on the signature for cell-mediated rejection. And then, I think impressively, they were good at saying when the biopsy was normal. So out of 109 normal biopsies, 100 showed the appropriate archetype cluster for being a normal biopsy. But 43 of the 100 that supposedly showed AMR histologically were called normal by the molecules, and 78 out of the 113 that had cellular rejection were called normal by the molecules. So this is from their discussion. They say, thus, as expected, disagreement between molecular and histology assessments was greater in heart than in kidney, particularly for cell-mediated rejection. The relatively high incidence of rejection in the population results from a concentration on indication biopsy samples. So rather than protocol or first year, biopsies, and the inclusion of relatively high risk sensitized population from Paris. So this means that the rejection phenotypes is higher than would be observed in unselected protocol biopsy samples. And again, I think this first statement's kind of interesting, especially if you think about their approach and starting with only the kidney transcripts and then seeing which of those kidney transcripts were relevant to heart, thinking about what they potentially could have excluded. I think that that's kind of obvious, stands out to me. So they also looked at DSA in this paper, and that's in table 3. And so they had 92 patients out of the 300 or 92 biopsies. So let's go back, sorry. This is a biopsy that had DSA taken at the time of biopsy that was positive. So 92 out of the 331 biopsies had a positive DSA, and only 38 of those showed a molecular signature that would have predicted AMR. And then again, it did well at the negative end, where 159 that had negative DSA at the time of biopsy, 133 were correctly called no rejection by the archetype cluster. So finish off discussion of this paper with just some of their discussion conclusions. So they say agreement of the objective MMDx kidney or MMDx heart system with histology assessment is currently similar to inter-observer agreement in histology. So again, going back, so they're saying that they called 42 out of 100 correctly, and they're saying that that's similar to the level of agreement that we have inter-observer wise in histology. And they quote the Cargo 2 trial, which you're probably familiar with, as the most sort of damning, the worst inter-observer agreement between local hospitals and the central reviewers of a bunch of heart biopsies that were done for the AlloSure test. And so they kind of cherry picked a study that had really terrible data on how well we agree with each other in reading heart transplant biopsies, which I admit is not perfect, but certainly it's better than 42% agreement. And so then they say, suggesting that at least some of the disagreement reflects uncertainty in the histology classification. So it's just curious that their conclusion of why they didn't have better agreement is that, well, our histology classification must be flawed. But they do admit that other issues such as sampling error could affect both methods. And then last, they say the expansion of the EMB sample size studied in the ongoing prospective phase. So after this paper, they started a clinical trial called the Inter-Heart study, where they're going to use this test prospectively. And so they kind of give a prelude saying, wait for more data as we accrue in this Inter-Heart study and apply this test to more heart transplant patients. All right, I'm just going to keep going through the next paper, and then let's just do discussion at the end. Is that all right, Peter, Mark? Okay. So enter the 2019 study. And you'll kind of notice one interesting thing, the Paris group has dropped off of this. And for the Inter-Heart study, they have some different centers that have joined. We'll kind of show that in just a minute. But so this paper, the idea was now moving from the origin story of this test to how they decide to report this result as a commercially available assay. And so their aims were to test whether diagnostic algorithms derived in one biopsy set, so the 2017 paper work, would be applicable to the larger sort of validation cohort. And then to determine whether incorporation of injury estimates affected the estimates of rejection, to develop new supervised classifier equations trained on rejection diagnoses, and integrate many estimates into an ensemble that reported the molecular and injury phenotype. So come up with a report that talks about rejection, it talks about this thing they're calling injury, and putting it into potentially an automated, user-friendly type of product. All right, so our analytic validity and clinical validity. Analytic validity, they give zero information about their assay performance, extraction efficiency, like all that stuff. There's not even in the supplemental table. So like we just take their word for it, I guess. And the chip technology is fairly robust, admittedly, but they don't provide any data on that. And then in terms of their population for clinical validity, a third, or I guess about a third of their population is the exact same patients that we just talked about in the 2017 paper, the 331 cohort. And then these additional cohort came from other centers that they've added since with the Inter-Heart study. And I think it's helpful here a little bit to see that these seem a little bit more reasonable or a little bit more comparable to what I think of as the usual incidence of rejection in a transplant population. One quick thing in terms of their data here, I don't know why they don't use the ISHLT system, but when they say P TCMR here, they mean 1R. So the P is, they're calling it possible T-cell mediated rejection. So this is 1R. TCMR is the 2R and 3R rejection. And so at least in this new cohort, they're seeing a lot more 1R than 2R, thankfully. And the AMR, it's kind of the same thing. The P means it's a PAMR1H or PAMR1I, and just ABMR is PAMR2 or PAMR3. And instead of being like a third of all their patients, it's less than 10%, 3% for each of those categories in this new cohort. All right, and then 44% with no rejection compared to only a third in the last cohort that had no rejection. So I'm trying to be helpful over here, giving you the ISHLT translation of these categories. And then this is different than the archetype clustering and archetype scores that they were doing. They now have this sort of expert diagnosis way of interpreting the gene expressions and dividing it into these patterns. But the performance hasn't changed a whole lot in the whole set. And also, I'm not really sure why they combined. I mean, if you're doing a training validation set, you don't group all the groups together. They should probably have done this analysis just with the new cases, but this is how they did it. So out of their 2R, 3R, and 1R cases, so a total of, I don't know, in the mid 300s, this is how many they detected as a molecular signature of cell-mediated rejection. So just as bad, kind of as we saw in the last paper. In the 100 or so patients that had AMR, they're getting about half, so less than 50% agreement between their molecular signature. I guess we need to combine all of these, right? But not awesome performance of that assay. And then once again, for no rejection, actually they did do really well. So 279 biopsies called normal by molecules out of the 334 that were called negative by, it's moving around, histology. And so how do they interpret this? They say the molecular results suggest that histologic cellular rejection, grade 1R, is in heart transplantation is seldom true TCMR. So they're equating the molecular signature as the true gold standard definition of cellular rejection. So all of those cases that were called 1R but didn't have the molecular signature, well, they must not be rejection. So that's sort of where they're coming from on this. And they're saying, well, that pathologists and clinicians have long suspected this. And certainly we don't treat 1R. It can go away by itself. But I think that's kind of a strong statement to make. And then they say MMDx shows some positive TCMR and ABMR biopsies where histology is negative and vice versa. And they're going to continue to study this in the InterHeart study. And we're almost done. So the other conclusion of this paper is that the results present a picture of the distribution of rejection phenotypes in the prevalent heart transplant population. I'm not really sure what that means. That's out of the way. In both indication and protocol biopsies, MMDx diagnosed AMR and no rejection more frequently than histology. Histology diagnosed cellular rejection more frequently than the molecules. But these histology TCMR biopsies often bore little resemblance to the TCMR in molecular terms. So my quick summary of these two papers, certainly we need to do better in the histology side of scoring biopsies, and certainly the molecular means of evaluating rejection would be of great value to transplant patients. It would offer reproducibility, objectivity, and subcellular alteration. But the way that kind of test is developed, especially with respect to analytical and clinical validity, is really critical. And I think from these papers, my confidence in the ability of this test to be that magic molecular test that always tells us the things that we can't tell from histology is pretty low. So they gave no basis to assess the analytic validity of their test. I think there's some flaws really with the way that they've done their clinical validity in terms of their population and what they're showing in terms of agreement between their molecular profile and the histology is really poor. The second paper I didn't go into very much, but talks a lot about things like this injury pattern and other archetypes. They have another paper that talks about early injury versus late injury. But for me, it kind of comes back to if their agreement between histology and the molecular classification of rejection was less than 50%, well, what's my confidence that they can molecularly establish something that looks like injury at the tissue level or early or late changes? We mentioned a couple of the other things like the effects of quilty and biopsy site not being accounted for in the MMDx test. It's also an invasive, it takes tissue away from being able to look at under the microscope. So it doesn't really have the same advantages as like the cell-free DNA assays, for example. It's just a blood test. And I think the validation strategy was really subject to sampling issues, and we sort of talked about that whole issue too. My last thing that I just want to show is the website of the company that offers this test, Thermo Fisher and One Lambda, has this disclaimer. You have to make a couple of clicks on their website to find this, but I think this is important for us to sort of have and talk to our clinicians about, that the people who offer this test themselves say that it is not intended to provide information for the diagnosis, prevention, or treatment of disease, or to aid in the clinical decision-making process. I've been at some of the marketing presentations made, and they definitely were trying to do all three of those things, but on their website, at least, there is that disclaimer. So I hope you're still awake. I'm sorry we didn't get you these papers in like last week or more time to review them, so that you could come more prepared to talk about stuff and disagree with me and my interpretation of the data. But I'd love to hear comments, and let's get a discussion going about these.
Yeah, very good. That it's a very interesting, and you really highlight the point of all both papers. So thank you. Any questions about that? And let's start a discussion. While everybody is preparing for the discussion, I have two questions about the approach, especially about the second paper. They talk about this tissue injury, and all these markers come from kidney or come from heart.
So they also came from the kidney. You know, again, they have limited their set to the kidney world, and I'm sure many of those are translatable to heart, right? But and that one was also a supervised approach, where they sort of looked at a list of genes and said, like, well, I bet that one has to do with injury, and this one probably has to do with injury. And so they defined what the definition of injury was going to be, which, okay. And I guess looking at histology, maybe there is some gray area in terms of what injury looks like. So in terms of coming up with a more unsupervised approach, that'd be difficult too. But I think it's important to realize their injury model was from supervised cherry picking. Well, I think probably some fibroblast things and some monocyte things and some natural killer. I don't know. They just sort of invented a recipe that they call injury, and then evaluate the biopsy based on that. But it did start from the kidney transcripts that they identified. This whole group started with kidney.
But from my naive thinking, when we pathologists talking about myocyte injury, we're really talking about cardiomyocyte injury, right? When we use the definition.
Yeah, and last time I checked, there aren't cardiomyocytes in the kidney, but
we cannot hear you.
Dylan, that was a very nice presentation. This is Max Buyo.
hi, Max.
Hi. I've seen these presentations from representatives of this group, and I still don't understand, you know, how it's decided what genes are really indicative of rejection or injury or whatever. It's they show all of these fancy curves and graphs and everything, but I just think that the underlying basis for it is kind of shrouded in mystery as far as I'm concerned.
I share that opinion. I'm trying to remain objective through all of this. And
Well, you're very good at that.
But I definitely share that opinion. This is a classic example in my mind of a glossy 6-page report that gives you an answer, but almost no, you know, data or science behind that answer. I mean,
Yeah,
you can make
I
a
mean,
glossy 6-page report that says anything.
but as I mentioned in an email comment today, I mean, there's just this overwhelming desire for non-invasive testing and quick testing and a number that you can, and that's very powerful.
And you noted, I didn't really summarize any of their thought process in terms of how they arrived at those clusters and how they applied to those clusters. A, because like, I'm not a molecular guy, but B, it's not really there in these papers. It's a very high level, very and I think another big, so obviously the cancer world is way ahead of us in this. There's so many gene expression tests for cancers. And I think because there's so much of that work, there are, there's meaningful peer review in groups, looking at each other's work and as they develop these cancer assays. As far as I know, this is the only group that's sort of taken this approach in transplant. And I don't think there's really the expertise out there when these papers came for review, for example, for somebody to say, from a gene expression profile development standpoint, I don't think it got the level of review it probably needed.
And then the other point is, that particularly early on biopsies can have grade 2 cellular rejection, foci of myocyte injury with C4D diffuse uptake, and a Quilty lesion. Now, I challenge this molecular microscope to figure that out.
Yeah, so now Richard.
Yeah, so I want to echo what Max said. Nice job, Dylan. That was terrific. So I found it interesting that the things that they had the best correlation on were no rejection, where it's very likely that the one piece that was selected for the molecular analysis looked like everything else. There was nothing present. Also interesting that the AMR had a better correlation than did cellular mediated rejection. And again, without knowing what they're looking for in terms of transcripts, it still makes some intuitive sense that whatever signature that they are ascribing to antibody mediated rejection would be something that would be diffuse, whereas all the cell mediated rejection is going to be incredibly focal. So I was curious why they haven't looked at how good their signatures are on material taken from a slide where there is honest to God rejection, where you can do direct correlation. We have the technology to do that.
Exactly. I'll just observe that they are pretty wedded to that microchip, the Affymetrix technology. I think much of this space has moved onto like ICJ's comment there, much of this has already moved to RNA-seq on a next gen kind of platform. But since they've put so much into this as a company developing the test using this machine, they're reluctant to move onto something, even if it might be better. Yeah, I think that's fair.
Yeah, I'm gonna say that if you go back, and I'm pretty sure if you go back to the original work, they were in competition, the Edmonton group, with CareDx or the AlloMap XDX test. And both of them were using Affymetrix arrays because that was what was available. This tells you how old this technology is, or these discoveries were. That was what was available back then before you had a lot of RNA sequencing, which we would use now. And so they were somewhat dependent on the number of probes that they had. So the first studies were on a very small, relatively small number of probes or potential genes or transcripts. Then the second study was more. But I feel like maybe for FDA purposes of where this has gone and how long it takes to get something approved, they've wedded themselves, as you said, to this older data set, and that they really need to redo this with better tools. The correlation between RNA sequencing expression results and Affymetrix array results is not very strong. And they're more likely to find better targets with RNA sequencing than they will with the array data that this is based on. Particularly, as Dylan said, this was really somewhat dependent on what they had already found in kidney and doesn't look at differences between renal rejection and cardiac rejection. The data speaks for itself. I just don't think there's enough there that it would convince me to leave biopsy and histology for their results, which are very wishy-washy when on the positive side.
And back to Rick's comment, Peter said I could only have 2 papers, so we only did, I'm just teasing. But in a couple of other papers, they kind of break out the different components. And it's really interesting if you look at the different histologic classifiers versus their molecular classifiers. The AMR is almost superimposable with the macrophage transcripts, like it's the same. So I think they're probably hitting on surrogates, just like you said, and your point about AMR being more diffuse and so less subject to sampling error, I think is a good one. But there's a signal there, but I'm not really sure it's AMR as we recognize it or as it clinically would be defined.
So just from a big picture point of view, so if they want to pass this one, say this one is like invasive approach, right? This MMDx, they should show they are better from the liquid biopsy at least, right? Not exactly biopsy, right?
Yeah.
That's my naive understanding.
Yeah.
I think there's a real opportunity for someone to redo what was done in the cargo trial, showing our reproducibility, but in a way that was designed for us to be more successful. I put it in the chat, but that study was really designed to make us look bad, like we didn't know what we could do. And the MMDx people came to my institution and basically said, our test is better at distinguishing rejection than you guys. But they were really, when they were talking about us, essentially the difference in their test was only as good as our ability to distinguish between a 0 and a 2R. And as I said, my grandmother, I could teach to distinguish between a 0 and 2R in about 5 minutes, and she was dead when I said this. So it's just people who want the histology to fail keep pointing at this one paper, as Dylan said, which is really flawed, and there's really an opportunity there for someone to do a better job in that space.
Don't you think our society is in a good position to do this? Yeah, I think we have the expertise and the spectrum, right?
We do. I guess, Peter, since you mentioned the liquid biopsy, and that's a topic for another day, but I think these cell-free DNA technologies make a lot of sense. And I think they're very sensitive. And I think the companies marketing these and the discussions I hear about this is they completely understand that it's not specific to rejection. It just means there's, myocytes being damaged and releasing their DNA into the bloodstream. And so they view it more as a screening test that needs to be confirmed. And I'm fine with that, frankly. I mean, I think these cell-free DNA technologies have a lot of promise as a sensitive screening tool. I was gratified at the ISHLT meeting last month. Lots of papers about cell-free DNA, hardly any about MMDx, despite the size of the MMDx booth in the exhibitor hall. So hopefully our scientific colleagues will not drink too much of the Kool-Aid, but yeah, we could talk about cell-free DNA another day.
Yeah, I think that's a very interesting topic. And that's really complementary to our histological observation. Any more point? Any further discussion? Anybody want to join?
Well, who in the group, what is going on at your own institutions in terms of using this thing?
We don't, here at Yale, we don't use anything.
What I think is going on at my institution is our guys are ordering all this stuff, but they don't tell me. And they're sort of testing me to see. That's what I think's going on at our place.
Well, actually, I only see one paper from Baylor.
And it's made, and the COVID has made it worse. I haven't been up to the 23rd floor to the heart failure center in 2 years.
I was going to start to say you would probably know, since it's a tissue test, because they would need the pathology lab to be involved in sending the tissue out, unless they take a piece in the cath lab and send it, and you don't know.
Well, I heard the other day, oh yeah, we're doing the cell-free DNA.
Oh,
And that's just a blood test, so that could be, yeah.
It'd be nice to know the results now
Yeah.
and then.
So we have 4 hospitals that do transplants, and only one, our university hospital here, is using it because they're part of that inter-heart study.
The kidney people are the ones that really been pushing it at
Yeah.
our place.
We do get it on almost all the kidney transplants here too. Yeah.
We don't use any of those tests here. The cell-free, I think, is very provocative, and that's worth a look. The original CareDx test wasn't of any value, and when we evaluated, it just wasn't worth it.
so any more questions? So anybody want to join Mark to that big study to clear? We are better than that 40% inter-observer experience. I think that's a very good, that'd be a very good project. If it, I will join you. Anyway, I think this is a very good discussion and very relevant for our clinical practice. Thank you, everybody.
So we're going to publish a summary commentary of this, these journal clubs in cardiovascular pathology.
Yeah, and one interesting point is we will add the interesting point from this discussion to have, so everybody will contribute this potential publication, right?
Yeah, sure.
Thank you, and hope to see you next time in 1 month period, right?
Thanks for
See you.
tuning in. Go sign out your heart biopsies.
Thank you.
Thank you.
Thank you.
Thank you, Dylan.